Okay, class, today we're in lesson 15.2, two-way relative frequency tables. Lesson 15.2, two-way relative frequency tables. Essential questions. How can categorical data be organized and analyzed? How can categorical data be organized and analyzed?
Oh, hi. This is practicing my guitar, which reminds me of a really interesting math question. So Ross has been teaching music lessons for 3 years. I might actually want to contact Ross and see if I can get some help with my guitar playing. The table shows the types of instruments played by his 40 students, and you'll notice just drums and guitar. Our mission is to make a table of the joint and marginal relative frequencies, and then figure out what is the probability that a student who plays guitar also plays drums. Okay, so here's the data we're given. We're given that 10 of his students play both drums and guitar, 12 of his students play the drums but not guitar, 15 of his students don't play the drums but play guitar, and 3 students don't play either. Which means I don't know what they're doing with them, because why would he be taking lessons if that's... Maybe he teaches something else too. Anyway, let's not worry about that right now. Let's actually consider how we would put together these frequencies. So what we would consider is... Oh my, I don't want to break my guitar. Okay, what we consider is a table that looks like this. And to find these frequencies, of course, we're going to look at the ratio of the number to the whole. So we know we have 40 students total. 10 of them, in fact, are yes, yes. So that's going to be 10 to 40, or 10 40ths, which is 1/4, which is 0.25. So this is 0.25. And I would similarly fill in the table accordingly. So I would take 15 over 4, 40, and so forth. And if we fill in all those ratios, which I won't do right now, we'd get this. And again, if we add up these two numbers, we get the total here. If we add up these two numbers, we get the total here. If we add up across these two numbers, we get this. These two numbers, we get this. And notice that it's always the case that if things are done correctly, the sum of this column should equal 1, and the sum of this row should also equal 1. So there we have the actual frequency tables that we wanted, both the joint and the marginal frequency tables. But now here's the question. What is the probability that a student who plays guitar also plays drums? That a student who plays guitar also plays drums. So we have to look at all the guitar people, and we see, in terms of the percentage, we see that relative frequency is 0.625. And out of that totality, how many of them also play drums? Well, the answer is 0.25. So the probability, which is total number of successes divided by the totality, would be, in this case, 0.25 divided by 0.625. Let me say that again. Why? Because we want to know, out of all the people that play guitar, how many of them also play drums? So this is the percentage, if you will, or the relative frequency of those people that play guitar. And out of that, how many also play drums? That's this. So I look at this ratio, and if you were to divide this, you see 0.4. So the probability is 0.4, or 40%, that a student who plays guitar also plays drums. So kind of a neat musical example, but the important thing is that through these different joint and marginal frequencies, it's like music to my ears.
Okay, now let's take a close look at example 1. Calculating conditional relative frequencies. One other type of relative frequency that you can obtain from a two-way table, from a two-way frequency table, is a conditional relative frequency. A conditional relative frequency is found by dividing frequency that is not in the total row or the total column by the frequency's row total or column total. Example 1. From Maria's two-way frequency table, you know that 22 students are girls and 15 students prefer cats. You also know that 9 students are girls who prefer cats. Use this to find each conditional relative frequency. A conditional relative frequency that a student surveyed prefers cats as pets, given that the student is a girl. Find the conditional relative frequency that a student surveyed prefers cats as pets, given that the student is a girl. To do this, divide the number of girls who prefer cats by the number of girls. Express your answer as a decimal and as a percent. So we can see right here 9. See that 9 right there? You also know that 9 students are girls who prefer cats. So that would be 9. Now the 22 comes about because from Maria's two-way frequency table, you know that 22 students are girls and 15 students prefer cats. So 22 are girls. So 9 girls who prefer cats divided by the total number of girls. When you divide that out, you come out with 0.409 and convert it to a decimal. You move it 2 places, 1, 2, and you end up with 40.9%. Okay, B. Find the conditional relative frequency that a student surveyed is a girl, given that the student prefers cats as pets. Divide the number of girls who prefer cats by the number of students who prefer cats. Express your answer as a decimal and as a percent. The number of girls who prefer cats was 9. The number of students who prefer cats was 15. So 9 divided by 15 is going to give you 0.6. Convert that to a percent by moving your decimal 2 places, and you come out with the answer of 60%. All right, the following is based on example 2. Finding possible associations between variables. You can use conditional relative frequency. You can use conditional relative frequency to see if there is an association between 2 variables. Example 2. Maria conducted her survey because she was interested in the question, does gender influence what type of pet people prefer? If there is no influence, then the distribution of gender within each subgroup of pet preferences should roughly equal the distribution of gender within the whole group. Use the results of Maria's survey to investigate possible influences of gender on pet preferences. Step 1. Identify the percent of all students surveyed who are girls. That's going to be 44%. Okay, step 1. Identify the percent of all students surveyed who are girls. That comes out to be 44%. Now they got this information from page 448, looking at her two-way frequency table. There were 22 girls and there were 50 students altogether. So 22 divided by 50 would give you 0.44. When converted to a percent, it would give you 44%. All right, now step 2, you're also going to need that same table from page 458. Determine each conditional relative frequency. Of the 22 students who prefer dogs as pets, 10 are girls. Percent who are girls, given a preference for dogs as pets, would be 45%. Of the 15 students who prefer cats as pets, 9 are girls. So percent who are girls, given a preference for cats, would be 60%. Of the 13 students who prefer other pets, 3 are girls. Percent who are girls, given a preference for other pets, would be 23%. Now, so you can see the table better, I wrote out the fractions here. So here would be 10 divided by 22, which ends up being 45%. Here, 9 divided by 15, which ends up being 60%. And then here would be 3 divided by 13, which ends up being 33%. All right, so to go back over step 2, once again, determine each conditional relative frequency. Here we ended up with 45%. Of the 15 students who prefer cats as pets, 9 are girls. So percent who are girls giving a preference for cats ended up being 60%. All right, that would be 9 divided by 15. Of the 13 students who prefer other pets, 3 are girls. Percent who are girls giving a preference for other pets would be 23. That's 3 divided by 13. Now for step 3, interpret the results by comparing each conditional relative frequency to the percent of all students surveyed who are girls. The percent of girls among students who prefer dogs is close to 44%. So gender does not appear to influence preference for dogs. The percent of girls among students who prefer cats is much greater than 44%. So girls are more likely than boys to prefer cats. The percent of girls among students who prefer other pets is much less than 44%. So girls are less likely than boys to prefer other pets.